This is supposed to be close to the hydrogen. Okay, well, it's the same deal where we have to draw the new product, including the lone pairs for this problem. Oh, well, I left out some arrows. That didn't make much sense. Here we go. Here's some more arrows. So now we're supposed to draw the product, including the lone pairs. Good. All right, well, it's good that you put in numbers. We can go one atom at a time. So this carbon number 1 is attached to 3 hydrogens and to carbon number 2. Carbon number 2 now has only a single bond to oxygen because we're breaking the pi bond, and it's got a bond to carbon number 3. We can see that the oxygen here is forming a bond to this hydrogen. And the hydrogen is losing the bond to this oxygen. And it's good that you saw that the number of lone pairs here is unchanged, because the oxygen is not using its lone pairs to form this bond, it's using the pi electrons to form the bond. So it has the same number of lone pairs as before. This carbon number 3 is attached to 2 hydrogens, but it's not attached to carbon number 4 anymore, because we're breaking this bond. Who is carbon number 4 attached to? Well, it's got a double bond to this oxygen. That hasn't changed. And it's got a bond to this oxygen, but now it's got 2 bonds to the oxygen. And this oxygen also has not changed the number of lone pairs, because it's not putting the new electrons in a lone pair, it's putting them in the pi bond. This would be a good example where it would pay for me to go back, because it looks like I didn't notice something. I didn't notice that the number 2 and the 3 now should have 2 bonds, but I think you got that right, so that's good. They already had 1 bond, and now we're forming a new bond over here. So it really pays to go through the whole thing twice, because it's easy to leave something out. Did I get this right? Does that look good?
Mm-hmm.
What about charges?
It stays as it is.
Yeah, that's right. And why is that?
Because it just changes the number of bonds, it doesn't exchange, just leave lone pairs like that.
Okay. I don't know if I followed your logic there, but you might have been right. That might have been right. I would think about this in an easier way. There's no initial tail or final head here. We simply have a cycle of arrows. When there's a cycle of arrows, you don't change any charges. Everybody here is both gaining and losing electrons. Maybe that's what you were saying. The hydrogen is gaining these electrons and losing these. The oxygen is just moving these electrons from here to here. This carbon is losing these electrons but gaining these. Everybody here is at both a head and a tail. So when you have a cycle of arrows, you don't change any charges. So a second ago when I gave you that problem with the cycle of arrows, I actually thought that would be too hard for the midterm, but I guess it wasn't. So you might see a cycle of arrows on the test, and that's the one case where you don't change any charges, because there is no initial tail or final head. Well, let's check that. The initial net charge was 0, and the final net charge was 0, so that's good. You might want to redraw this, because what would be the geometry around this carbon? Yeah, and it probably wouldn't matter on this problem. They're probably not going for the geometry in this case. In any case, it's good to start with a picture that looks like what you started with, and then you can make it prettier later if you want to. This is probably not very important here. And again, you really only have to draw these lone pairs because they asked you to on this midterm question. After the midterm, we're usually not going to draw a lone pair unless we need that lone pair to be at the tail of an arrow. They just clutter up the picture. But on the midterm, it looks like they want you to keep track of those as well. All right, well again, the organic chemists think it's really cool that they can give you this complicated reaction that you've never seen before, that you don't know anything about, but just by giving you the arrows, you can figure out with no guesswork what the product is going to be. And because they think it's cool, they write test questions about that. So it's important that you prepare for this. And like I said, you're going to really need this skill after the midterm as well, because the instructor is just going to assume from now on that everyone is a master of working with these electron-pushing arrows. Whereas most students who look at this, if you ask most students what would be the product, they would say, well, how the heck should I know? I've never seen this reaction before. They don't realize that the arrows tell us exactly what to do. So if we take our time and put in numbers and work one atom at a time and change 2 charges at the initial tail and the final head, the arrows really take out all the guesswork. It just takes a little practice. Like I said, this was also worth going over because you use very similar arrows for resonance. Again, the resonance arrows tell you which bonds to form, which bonds to break, and which 2 charges to change. Why isn't this resonance, by the way? That would be a good test question.
Because it's changing the structure. It's like a completely different molecule.
Yeah, that's right. But how do we know it's changing the structure in a way that isn't resonance? The key thing is resonance is when you're just moving pi electrons around. But here, the biggest clue that this is not resonance, well, first of all, we're forming 2 new atoms, so it can't be resonance. We're also forming new sigma bonds. Anytime you break or form sigma bonds, it can't be resonance, because resonance involves only moving pi electrons and lone pairs around. Resonance involves only pi electrons and lone pairs. That might be something you might see on the test. Why is this not resonance? Well, if we're only moving pi electrons and lone pairs, pi bonds and lone pairs, that could be resonance, but this can't be resonance. Okay, good. These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm. Or you can just use the link in the info box. Thank you.